Now we're going to do our Q&A and panel discussion. A lot of the questions were answered already by the speakers. I'll ask them to join me now with their cameras and and go off mute, and then we'll just take a few more questions as we finish out our time today. And I'll just go ahead and stop sharing the screen here. Okay, let me start with a question about future trends. What areas, this is for all of you, what areas are you most excited about, the things are on the horizon that you're watching? I think maybe, Meghna, you're the only one on at the moment, so you want to take that one, if you don't
Yeah,
mind?
I can take it. So for me, really three things come to mind. I think there's like really great work being currently done with model interpretability and really understanding what our models are doing and how they function. The second is fair and ethical AI. I think we need to take a step and like really understand like if the models we're building are fair and equitable to everyone who we want to use, like who we want to put into products and like have everyone use these models. So it has to really represent all populations. And then the third thing I think is AI policy and really like how we do modeling within our companies and making sure like BIPOC and women are part of the modeling process, and that we work on passing legislation for AI policy that helps people truly understand what's happening in the models, that the products that they use. Yeah, those are my three things.
Cool. Liam, any thoughts on that question?
So just to so the question was, what do we see on the horizon? Machine learning. Yeah, I think for me, what's really exciting is the democratization of machine learning and sort of the things that sort of efforts in neural architecture search and other parts of Otto ML and also open source to make machine learning cheaper and more accessible for users that are not Google, Microsoft, and so on. So I view some of the more efficient Nass methods as efforts to democratize machine learning, and I hope we'll see more and more work on kind of more efficient ML, which is important both for the environment and also just for more people to be able to use it. From the startup side, I think RayTune, Ray, Determined, there are a lot of companies that want to solve this problem, and hopefully we'll see some more high impact solutions in the future.
Cool. All right, Richard, no pressure. I think you might be on mute, Richard.
Can you hear me now?
Yes.
All right,
Sounds
awesome. I think the idea of democratization of machine learning broadly, not simply for programmers, but also for computer science fields, I think that's going to be a huge thing on the horizon. And along those lines, I think as we see machine learning permeate across all of these different industries, the need to train and the need to efficiently leverage our resources, as Liam had said just now, I think that's going to be one of the most critical parts, like the kind of the game-changing ways we're going to see machine learning in the future.
So the theme of this session was Otto ML, and somebody asked, what exactly is it? We didn't really define it except kind of by sort of implication. And I thought of this because you mentioned just the democratization aspect, and part of Otto ML's goal is to make things more automated, easier to use, less expertise required, and so forth. I wonder if you guys have any more thoughts about what Otto ML means to you when you think about that term.
Yeah, I can go first. I answered in the comments here, and I think for me, the typical understanding for when someone says Otto ML is you have some black box function and you're given some dirty data, and somehow you tell the black box function, hey, I want to detect where like the person is, and the black box function just like crunches a bunch of numbers, and then you get this nice package that tells you that, or like tool that tells you where the person is in all the data. I think obviously we're far away from that, but we're seeing advances in both vision, robotics, reinforcement learning, and especially in natural language processing, that's going to make this more and more of a reality.
Any other thoughts on that from our panel?
I can go next. I think for me, Otto ML is basically what I presented on today. It's really to augment your workflow and make things easier and more informed than they were before. Like a lot of the talks today, like we saw processes that might have randomly been done or more manually done be actually informed by intelligent optimization systems such as Bayesian optimization. And to me, that's really the core of Otto ML, is really like an augmented workflow. Yeah.
Yeah, so to add to what the other panelists have said, I think, so I agree with what Auto ML is. As for kind of the future of Auto ML, something that I'm really excited about is in some sense similar to crowdsourcing, but I kind of think of it as meta learning for Auto ML. So instead of tuning each workflow independently, how do you learn from previous experience and related problems? And I think certain approaches to meta learning for AutoML are kind of limited right now because we don't have a repository of that experience. And if we can create a repository of that experience, I think it will have a lot of value to anyone who wants to use AutoML in the future. So you can benefit from an experiment that someone else has run before. And it'd be great if we can all think of a way to crowdsource that experience and share it.
Okay, good. Liam, I had a follow-up question for you, and that is, you sort of mentioned at the beginning how people often gravitate towards well-publicized models like CFAR and so forth. But I guess that's a data set. But anyway, these different model architectures. And I wonder if you think the problem of Nass will slowly go away as people just standardize on popular architectures and hence reduce the search space that they're worried about.
I think we've seen kind of the opposite thing, right? So we've seen people move from very popular architectures to trying to learn specialized architectures for their problem. It could be this case that we will kind of move back a little bit to sort of less learning specific architectures and more kind of default things that people use. And I think it's actually a benefit of Nass because so people that work in Nass perform research, and companies that have published papers, they release the architectures that they found so other people can benefit from kind of all the compute that they've spent to find these architectures. So I think it's good that we're able to like take the work that Google has done using thousands of GPU days and hopefully boost the performance of our models. But I don't think it means that we should completely just rely on existing models, especially for problems that people haven't really solved before. So maybe it's a completely different set of images. It's not ImageNet, it's some sort of biological images or other types of images where we don't know what the right kind of implicit biases are for this model. And then we would need to do architecture search there. So I think it will be a mix. There are certainly places where I think Nass will be useful. It's to be seen whether things are robust enough to be applied widely yet, but I'm hopeful that eventually it will be.
Cool. Richard, I was wondering, when you think about the general problem of hyperparameter optimization, are there some big areas where you think a lot more work needs to be done to make it more efficient and so forth?
I think so let's see, there's I think two answers to that question. The first is, how do we leverage elasticity of cloud resources? So basically right now you can imagine hyperparameter tuning being like a large, long, time consuming, expensive box. But one question here is like, how much can we squeeze the box so that you leverage parallel compute as fast as possible, as much as you can, so that the box becomes as thin as possible. So you can imagine like the end goal of here is you pay the same amount of money, but within 1 second you can get all of your models trained and tuned to the best hyperparameters possible. I think that's one area where that we should really be looking forward to the future. And the second one I would say is similar to what Liam has mentioned about this repository of previously trained data and the sort of like meta learning approach. I think there's a lot of wasted compute in hyperparameter tuning and Otto ML. And if we could just leverage, some of these past traces, some more information about what we're doing when we're doing the training, and teach the hyperparameter optimizer what were good things that we did in the past and what were bad things that we did in the past. Eventually, I can imagine hyperparameter tuning today will just look like archaic and antiquated, because in the future everything is going to be super simple, because and is able to leverage all this history of people training models in order to create new tasks or to create new classifiers and stuff like that.
A question for you, Magda. Some of these NLP models like BERT are absolutely enormous. And I love the idea of the kind of stuff you were working on to find the right balance between performance and size. And I wonder how far you can think we can go there, and what techniques maybe that people like yourself can apply to reduce the size while still achieving the necessary performance.
Yeah, totally. I'm going to speak to it from an optimization perspective as well. I'm not an expert in compression, but like we have seen a lot of companies try to do this with different compression techniques, which can essentially be optimized. Like for example, Russ's technique is pruning during training. So like figuring out which things to prune is not easy, which is why we suggest doing intelligent searches like Bayesian optimization to kind of understand what to take out and what to keep in, and having it be a more informed cycle than before. I think that the general compression of these models is highly required. I think it's great that we're producing really large models that are high performing, but if we can't put them into products or put them into production easily, there's really not much a lot of people can do with them. This kind of speaks to what Liam and Richard said about democratizing AI and like ML, and making sure models can actually be trained and used by everyone who's not Google or Facebook or have like enormous computes available to them. So I think the technique itself will go really far, and like we've seen more teams and more groups coming out with more compression techniques and more work in understanding what the compressed model has learned compared to the teacher model, because we want to keep them as high capacity as possible. So yeah, so I think it's going to be like a huge thing, and we should look out for that. Like I think AWS is actually working on something right now, or published something recently on it. So yeah.
Okay, very cool. Well, we've gone over a little bit on time, but I want to thank all three of you for joining us today. It was a fantastic set of talks and a great discussion afterwards. And thank the audience for tuning in. Once again, we'll post the events, the recordings rather, and slides very soon. And you can find out more about our next events at anyscale.com/events. Thanks again.